Start recording. Okay, 12.1 magnetic field. Magnetic field is the distribution of the magnetic force in a region of the magnet. So we have a magnet, right? And it has a north and south pole. Here is south and north pole here. If you bring these two magnets to each other, the north and south will attract each other. Okay, how do we know? If we have those magnet powders, like iron powders, they will be alone and show you these awesome patterns. So it's showing the direction of the magnetic fields. You see, they are connected to each other, right? Direction of the magnetic field is always from north to south. If I want to put the direction here, I just put direction here, like that. And when the south and the south poles come together, this field repel each other. And that would be something like that. You will see the pattern of the iron shaping like this. They kind of won't connect, right? They they repel each other. So these lines repelling these lines. Okay. And again, it's gonna be from the north to south, something like this. North to south here. It's north to south. Okay. Better picture. We'll see that. This is a magnet by itself. The magnetic field is from north to the south, and that's the pattern. If you realize when you are very close to one of the poles, these lines are very close to each other. It means you have very strong magnetic field close to the poles, right here and here. But when you go away, so the distance between the field increasing. So comparing the distance between the fields here and the distance between the fields here. When you're close to the pole, the distance between each field is very small, means very intense, right? So have a very strong field here. As you go away from that magnet, the field become weaker as the distance between the fields decreasing. I'm gonna go with simplify that. So again, like poles attract, like poles repel, and the one that is are not like each other, so they attract each other, right? We have some magnets, and let me just write that. So magnets attract other magnets. So we know the opposite poles attract each other. Now, what about a magnet, an object that isn't a magnet? So you know that some metal can be attracted to a magnet, um, despite of that not being a magnet itself. Like what? You call this metal ferromagnetism. And these are the definition of the ferromagnetisms. We just read that through. So here is the domain theory. Okay. Every magnet made up of many smaller magnets and rotatable magnets. Okay, I will tell you what does it mean. We call it dipoles. So do you see these arrows? They are dipoles. They look like a magnet. They have a positive and negative end. When you're talking about non-magnetic material, these magnets are randomly distributed. See, this is to the down, here is up, the direction is randomly everywhere. But when we're talking about the magnetic material, uh, you will see the regions that some of them are aligned here, right? That's why this is the magnetic material. So we have the area that they coupled, right? And they have the same directions. And when you look at the magnet, all of these regions, they all align in one direction. That's why we have a south and north pole. So magnetic material, they have kind of the different areas that they have those magnets aligned. But for magnet, all of them align in one direction. For non-magnet, they are in random directions. Okay, so of course, these dipoles will interact with the other dipoles, right? So we call this one a domain, right? See, we have a small domain here, small domain, because all of these magnets here align in one direction. Here in another domain, they are aligned in different direction, but it still have those domains. Here we do not have that domain, right? Because all of them is just kind of randomly. And all of the domains here in one direction. Just make sure that you know the difference. Now we have some magnetic properties. So we have magnetic induction. Uh, so magnetizing ferromagnetic object when they encounter a strong magnetic field with fixed direction. Okay, what does it mean? Now, ferromagnetic objects, as you see these fields, we have those domains, right? If you put a strong magnetic field here, it will force this region to align in that direction and make them like a magnet. Now, if I have a very strong magnetic field acting on this ferromagnetic material, this little one will align upward. This little one align upward, right? In the direction of the magnetic field I'm exerting. And it become magnet itself, right? So magnetizing ferromagnetic object when they encounter a strong magnetic field in a fixed direction. Now demagnetization, ferromagnetic material lose their magnetic strength. So this could be with the time when you have magnetizing ferromagnetic object, it become magnet. But if you remove them from those magnetic field, then it will losing that property or that strength. So reverse magnetization poles are reverse, different for object with without electric current. Okay, I'm not gonna go through this one. Um, so that's just the maximum strength I'm gonna. For maximum example, if all of this domain here that you see here align in one direction and become like that, so the maximum strength of that magnet reached. Just saying about that maximum strength. Now looking at these magnetic fields, again we have these magnets and pay attention that these lines is from north to south. The direction is from north to south. And if you put this campus on way of those magnetic lines, see the red one will indicating the south, right? So it makes sense. So the direction of the south gonna be that way, right? Is another one. So again, it's from north to the south. And looking at the Earth, I know you call this one to be North Pole, but actually North Pole is the south of the magnet, right? So just put that here. If you just consider an Earth like a magnet, that would be the south of that magnet, and that would be the north. So notice you call this one North Pole, right, in Arctic, but actually that would be the south. Just the naming is kind of reverse. Anyway, now we could draw this. We know that the south and north will attract each other, and north and south here is attracting each other, right? So we will do that. Okay, just give me 1 minute.